There's really two things in calculus. One is derivatives, okay? And the second is integration. Okay? Integration is basically the area under a curve. Derivatives are looking at the slope of a tangent line. That's really all calculus is. It's those two things. However, there's a lot of subtleties in there, and you can't do either one of those things if you don't understand what a limit is. Okay, so this is going to be the new stuff that seems weird at first, like you've never seen anything like this. Okay, all a limit is it describes what the function is doing as x approaches a number. That's it. Okay, if I say what's the limit as x goes to 2, well, we're going to start with just graphs. You just look at the graph and you just tell me what is the function doing as you get closer to 2. What number are you getting closer to? What y value? That is it. Okay. It has new notation that you haven't seen before. Instead of writing the I and the T are too much work to write, apparently. So we drop those and we write lim as x goes to c, f of x, whatever the function is, equals, and you just put whatever your answer is there. Okay? So if we start with a function like f of x is equal to x cubed minus 1 over x minus 1. Obviously, x cannot equal 1. Why can x not equal 1? You'd be dividing by 0, right? Okay, so our function is x cubed over x. We don't know what the graph looks like, so the most basic way to do a limit is to do a table of values. This is the only table of values we will do for limits because nobody does this in real life, okay? So the table of values would look like this. So x value, y value. And we're going to try and find the limit as x goes to 1. So I just said you can't put 1 in there, right? But I want to know what the function is doing as we get close to 1. I don't care what happens at 1. Just what is the function doing as we get close to 1? So because we can't plug 1 in, we do a table of values, and we plug numbers in that are getting closer to 1. So we'll start with an x value of 0.9. Right? We're pretty close to 1. It's not 1, though. If you put x is equal to 0.9 into this function, I'm just going to give you the answers here. We're not going to actually do it. You can if you want. You get 2.71 is your y value that comes up. And then if I want to go a little bit closer, I can do 0.99, which will spit out 2.97. And if you want to get even closer, 0.999. So we're like bumping right up against 1, but we're not there. We get 2.997. 1 you can't do, so I'm not going to worry about that. Now, when you're doing a limit, you have to look at it coming from both sides, because sometimes you'll get different answers depending on which side you come from. So this is the side creeping up to 1. We're coming from numbers that are smaller than 1 and coming up to it. Now we're going to come down from numbers that are larger than 1. So 1, 2, we'll start out here. If I start at 1.1, plug it into the function, spits out 3.3. And then I move a little bit closer. So I'm like, okay, well, let's plug in 1.01. We're getting closer to 1, but we're coming from the other side of it. That gives me 3.03. Everybody here already knows the answer. What number are we getting closer to? Sorry? 3. Right? From either side, you're getting closer to 3. If you put in 1.001, you will get 3.003. And you can keep doing this, all right? But at a certain point, you're going to be like, it's 3. We've gotten close enough, okay? That's a limit. That's it, okay? Now, we're not going to do table of values because that takes a while to do, especially if the functions get quite complex. But you can see the y, as x gets closer to 1, the y values get closer and closer to 3. And if you look at the graph of this, So we would say, actually, let's just write the answer. The limit as x goes to 1 of x cubed over 1 is equal to 3. That's what that means. All right. And the graph, this is the graph of the function. I don't expect you to know this graph. We do a section on graphing later on. So it's sort of parabola-like. And you can see as you come down, if you come down from numbers that are bigger than 1, coming down here, we're getting closer to the y value is 3. And if you come from this side, we're getting closer to the y value is 3. Why is there an open circle there? Because you can't put 1 in, right? It blows up. What do we call that? Anybody remember from grade 12?
Oh, it's like the point of something, right?
Yeah, point of discontinuity. POD.
I thought the incontinuity.
All right, it's called a POD. We'll learn when it's POD and when it's in that vertical asymptote later on as well. Okay, so that's the visual. Now, obviously not all functions have undefined points. Okay, if they don't have an undefined point at the point you're going to, you just plug the number into the function. So for example, if I have the limit as x goes to 2, we'll do the same function. So this function, what we just did, has an undefined point at 1. But it doesn't have an undefined point at 2. So if I want to know the limit, all I do is plug in 2. Which is 8 minus 1 over 1, which is 7. That's it. So when you're first doing a limit, you ask yourself, can I plug in whatever number we're approaching? Okay? Does it make it undefined? If it doesn't make it undefined, you just plug it in and it spits out the answer and you're done. If it does make it undefined, then there's other stuff we have to do. Okay? But we're not there yet.
What if it's defined in every point, but there is like a jump? I mean,
we're going to get there too. So that the limit doesn't exist in that case. But we're going to talk about that in about 5 minutes. All right? Okay. So what's the first thing you ask yourself? Does it have an undefined point at 2? Does it? No, it doesn't, right? The only time you have an undefined point is when you have a variable in the denominator, right? Something like that. Or like that, or whatever, it doesn't matter. If you have a variable in the denominator, you have an undefined point because you're dividing, you can divide by 0 depending on what the number is. But if you don't, this is a polynomial. So it's continuous everywhere. Just plug it in. So what's the answer? 0. 0 is a legit answer. So that's the limit. So what's the first thing you ask yourself? Is it undefined at 0? Is it? What makes it undefined? -1, right? If I put a -1 in there, I get 0 in the denominator, and then it all blows up. But if I put 0 in, what do I get? I get √1, right? The top becomes 0. Anything divided by, or 0 divided by anything is 0. So it's just 0. -1. Yeah, yes, yeah. Yeah, any negative number that's, yeah, less than -1. But 0 is not in that domain, so we're fine. Okay. And if you look at the graph of that function, it looks like this. And then at 0, sorry. Looks like that. And this would be -1. Why did I draw a hole? Doesn't have a hole there. It has a hole at -1. Sorry. There's your hole. Like that. All right. Okay. Anybody know what a piecewise function is? So this is a piecewise function. Okay. This is a piecewise function. So basically it means it's defined in pieces. I know. Fascinating, isn't it? So we're going to sketch this graph. You have the ability to sketch this graph, okay, even though it looks all weird. So it says f of x is equal to 1 when x is not 2. So if I just said sketch the graph of y is equal to 1, what does that graph look like? It's just a horizontal line at 1, right? Except when x equals 2, what does the graph equal? 0. So this graph looks like this. Here's 2. At 2, our graph has a value of 0. Let me put that in red. Everywhere else, it's equal to 1. That's the graph. It's a horizontal line everywhere. This bit, whenever x is not 2. But at 2, it falls down to there. That means that has to be an open circle. All right. So if I said, what is the limit as x goes to 2 of this function, you would tell me. Who agrees with that? Who has no clue? It's 1. All right. If you look at it visually, if you come along from this side, you look at it from the left and the right. You come along this angle. I'm getting closer and closer to 1. It's the only number you can get closer to, right? And this side, remember, it's the number you get close to, you approach. It's not the number at that point. Okay? So the number you're getting closer to is 1. At 2, it drops down. I don't care what happens at 2. All I care about is what number are you getting closer to? Okay? So this limit is 1. That's, I think, the hardest thing for kids to understand, students, sorry, is it's what are you getting closer to, not the value at that point. All right. Come on. Okay. All right, here's our graph, or here's our function. I'm going to show you weird functions that you haven't seen before, but I'll show you the graphs as well. The absolute value of x divided by x. Does anybody know what this graph looks like? Okay, well, let's look at it two different ways. What does the absolute value function do to, what does the absolute value do to a function? It makes everything positive, right? So, you don't have to write this down. If I put x is equal to 1 in here, what do I get? You get 1, right? Because it'd be 1 over 1. If I put x is equal to 2 in there, what do I get? You get 1 as well. Does everybody see that? So that means when x is positive, I get 1 for everything. Can I put 0 in? Because you'd be dividing by 0, right? So you can't have a point there. When x is positive, that's going to be at 1. Now, what if I put in x is negative 1? So if I put negative 1 into the top, what does the top become? 1. What's the bottom? So what's my answer? Negative 1. So whenever you put a negative x value in, you're going to get negative 1. So that's the full graph. And you have open circles because you can't put 0 in there because it all blows up. All right? Okay, all I care about is the graph. Like, don't worry about this bit. So, if I said, what is the limit as x goes to 0 of this function? What would you say? Be quiet. What's the answer? If I come this way, what number am I getting closer to? 1. If I come this way, what number am I getting closer to? Negative 1. So if you approach different numbers from the left and the right, the limit does not exist. That is your answer. D and E does not exist. For a limit to exist, and I'll sum this up at the end, for a limit to exist, you need to be approaching the same number from the left and the right. Okay? We okay with that? No?
Yeah.
I know it's a weird idea, but number 7. All right. Here's our function. 1 over x squared. Anybody know what that graph looks like? What happens at 0, though? That's the key. So at 0, you have a vertical asymptote. All right. But the graph is always positive because you're squared, so it looks like this. So basically, as you get closer to 0, the graph shoots straight up. Okay? So if I said, what's the limit as x goes to 0? Sorry? It's infinity, which means it does not exist. Okay? Because you're not approaching a number. What number are you approaching? Infinity is not a number, by the way. Okay? So it just keeps going up. It doesn't get closer to anything. It just gets bigger and bigger and bigger and bigger and bigger. So because you're not approaching a single number, the limit does not exist. Okay? So when you get closer to vertical asymptotes, there is no limit. All right? Even if the graph, well, I'll summarize it, but even if you had a graph that looks like this, where it goes to different things like that, vertical asymptote, you're going to positive infinity, you're going to negative infinity, no limit. All right? Okay, one more weird one. There's no way you're going to know what this graph looks like. So I will explain. How do you know that? I will explain how you get there. All right. So now don't write any of this down. I'll just show you the graph at the end. Okay. But if you think of a sine function, what the sine graph, we drew it earlier, looks like this. It always oscillates between 1 and -1, right? Unless you put a 2x, you do a vertical expansion, but we don't have any of that. So the sine function or cosine only ever oscillates between 1 and -1, okay? So I know that this graph can only oscillate between 1 and -1. This is how, I mean, I know what the graph looks like just because I've done it before. But this is how you can think of it. I will not ask you to reproduce this graph. I will give you this graph if I want you to answer a question about it, okay? Now, I also know the graph of 1 over x, don't write this down. The graph of 1 over x looks like this. Okay? That's what the graph of 1 over x looks like. So as you get closer to 0, this value goes to positive or negative infinity. Okay? Does everybody agree with that?
Yeah.
That means that essentially, what do I write this? Write it over here. Again, don't write this down. All that you're responsible for is answering this question, not how to get the graph. That's essentially what you're doing as you get closer to 0. Okay? The sine function, you're just plugging in really, really big numbers, which are way out here, or really, really small numbers, negative infinity, which are way out here. The graph only ever oscillates between 1 and -1. So this is what this graph looks like. It comes in. As you get close to 0, it starts to flip back and forth really, 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 really fast. And it goes like this. I'll show you on Desmos. It does it like so fast you can't even distinguish it, okay? Now, so I would give you this graph, and then I would say, what is the limit as x goes to 0 of this function? As you get closer to 0, what number are you approaching? Are you? Because if you're here, put this x value in, you're up here. The next x value goes down here. The next one goes to there, there, there. You're not approaching any number. It's just oscillating back and forth. Okay? So if you get a function that oscillates back and forth like this, what's the answer? D at E does not exist. Oops. So you just say the limit of that function does not exist. All right. Let's summarize this. limits do not exist if 1, you approach different numbers from the left and right. So graphically, that would be a graph that looks like this. You'll see a jump. This is called a jump, right? Because the graph jumps from here to here or here to there. Okay? So if you have a jump at that point, the limit does not exist. 2. I'll write it in math speak, and then I'll just tell you what it means. F of x goes to positive or negative infinity. A mathematician would say it increases or decreases without bound, which means it just goes flying to infinity or negative infinity, i.e., it's a vertical asymptote. And then on a function or a graph, looks like that. And the third one, which we just did, is f of x oscillates between 2 fixed points. If you have any of those things, the limit does not exist. Okay, and that is your answer. D and E. You can write D and E on a test. Okay, and I will be fine with that. If it doesn't have any of those things, or it doesn't at the point you're going to, what do? Sorry? Just plug it in, right? That's the stuff back here. These ones, not undefined at these points, just plug it in, it spits out the answer. That's it. All right. Here are your questions. Page 55. 15 to 23 odd. 27, 67, 69, and then 37 to 47 odd as well. 37 to 47, we'll say this weird thing about epsilon delta. Don't worry about that, just find the limit. Okay? Stop this, I'll put it back up.